Happy Monday, everybody. We're gonna start our first lesson where we left off from last week. Um, Looking back last week, we learned how to use this box right here so that we could reverse factor this polynomial. All right, we need to fill in each part of the four parts of the box, and we start by entering the values for the first and last parts of the box. Now, we learned yesterday or Friday that let me make me a copy so that I can bring it back up. Okay, so looking at this box right here, we learned that you take this ax square right here and you put it in the first box. So we're going to put 6x squared in this first box. All right, and then you take your last digit, or the c as they call it, and you put it in this box right here. All right, so our first box is always going to be this first section with the exponent, and then our last one is always going to be this last number in the last box. So now we just have to figure out what would go in boxes 2 and 3. So let me remove that. Thanks. So let's look. All right, and they showed us that here. All right, so we know that box 2, or this box right here, has to be the factor, the product of. So we have to find all the numbers that would multiply together here to put in here. So let's show all the factors of 18. All right, so we've got 1 times 18, negative 1 times negative 18, 2 times 9, negative 2 times negative 9, 3 times 6, and negative 3 times negative 6. All right, so now we have to look at these factors, and because the product of a number has to go in here, we have to find which one of these have a sum that equals 11x, or our middle factor. So let me make a copy of this real quick so I can write on it. All right, so we're looking at this right here. So we have 18 and 1. And do they add? This equals 19. We have negative 18 and negative 1. So that equals negative 19. We have 9 and 2. That equals 11. We have negative 9 and negative 2. So that equals negative 11. 6 and 3 equals 9. And negative 6 and negative 3 equals negative 9. So do any of them equal 11? And yes, they do. So we have our 9x and our 2x. Those will equal 11. So now let's look at that. Our 9x and our 2x. Now we check our understanding. Can we factor this very complicated trinomial using the box method? All right, so let me bring this up so I can write on this one. Okay, so now that we have them in the box, we can now use this to factor out our trinomial. All right, so what can we factor out of these two? All right, we have a 6x squared and we have a 9x. Well, they both have x, so we know that we could have an x, right? All right, and then we have a 6 and we have a 9. I can't take anything out because this one's the only one with an exponent. So I can take out 1x, but I can't take out more than 1. And when this one has a 6 and that one has a 9, well, the only thing that they have in common is a 3. So I'm going to do 3x, and that covers this section. So now let's go to the second row. All right, so now I'm looking at these two numbers right here. We have a 2x and we have a 3. Is there anything that they have in common? And the answer is no, there's nothing that they have in common. So the only thing that can be factored is 1, because anything can be multiplied by 1 or divided by 1. All right, so now let me change the color of my pen here, and I'm going to go to blue. And I'm going to be looking at these two right here. I have 6x squared and 2x. Well, this one has x to the second, and this has x, so I know that I can take x. All right, and this one has a 6 and this one has a 2. What do they have in common? Well, the only thing is they both have a factor of 2, so I'm going to put that there. All right, and then we have 9x and 3. What do they have in common? Only one of them has an x, so I can't factor out x, but we have a 9 and 3, and we know that their common factor is 3. And here we have factored out our trinomial. So let's go ahead and put that in and see what we said. That this was 3x, 1, 2x, and 3. Wow, this keeps doing this. I'm not sure. All right. And that is correct. Those are our factors. So now we can rewrite this as two factors. 3x plus 1 and 2x plus 3. And we can check our work by going back and multiplying using our front, outer, inner, last method and multiply each one, and we would get 6x squared plus 11x plus 3. All right, this week we are going to be practicing this a whole lot. All right, but before we start practicing, I want to tell you about a couple of types of trinomials to look out for. All right, the box method gives you a useful tool for factoring any trinomial, but some polynomials follow patterns that will allow you to factor them quickly without using the box method. The box method could be used. It's a great tool, but you won't always need it. Study these two examples. The trinomial on the left, this one right here, is called a perfect square trinomial. Okay, so this one on this side is called a perfect square trinomial. The binomial on the right is called the difference of two squares. Do you see why? Take a minute and think about it. All right, the one on the left right here, this perfect square trinomial. The trinomial on the left is called a perfect square trinomial because it can be factored as a binomial x plus 3 squared. You can write it in factored form as x squared plus 6x plus 9 equals x plus 3 squared. Notice that the squared factor contains the square roots of the first and last terms. The product of these square roots doubled is equal to the middle term in the trinomial. So think about it. Think about all the squares you know. 2 square equals 4, 3 square equals 9, 4 square equals 16, 5 square equals 25. Now, if you squared them, think about the number it would be, but then what would the sum be? So 3 squared equals 9, but 3 plus 3 equals 6. So if you see that the last monomial is 9, and you see that the middle one is 6, then you know that this is a perfect square trinomial. You also know that if you saw, let's say, x squared plus, and we could put another perfect square at the end. Let's just use 5. So 5 times 5 is 25, and 5 plus 5 is 10. So this would be another version of a perfect square trinomial. All right, and these are ones that you could see easily and pick up on, and you wouldn't have to do the work of the box. All right, so now let's read up on the difference of two squares. The binomial on the right is called a difference of two squares because the two terms being subtracted, x squared and 4, are each perfect squares. Notice that one factor contains the sum of the square roots of the terms and the other factor contains the difference of the square roots. All right, so look at this. Let me take another. All right, so let's look at this. If you're looking at this trinomial, or I guess it's a binomial because it only has 2, it's different than the ones that we've been looking at before. The other ones that we've been looking at before are written as ax squared plus bx plus c. All right, this one is missing this middle part right here. It's gone. And the only way that something like that could be eliminated, where it was just ax squared plus c, is if the bx in the middle canceled each other out. And the only way that they can cancel each other out is if it was a difference of 2 squares. All right, so let's go ahead and multiply this together so that you can see that happen. All right, so we have the first 2 digits, x times x. So we'd have x squared plus the outers, so 2 times x, so plus 2x, plus the inners, or the opposite, so x and negative, so we have negative 2x. And then the last 2, plus 2 times negative 2 equals negative 4. So these two numbers right here cancel each other out, the plus 2x and the minus 2x, to where they're no longer there. And we get left with x squared minus 4. All right, so now let's look at when we'll see this again. Okay, so now let's think of other perfect squares that could cancel each other out. Well, we had one earlier when we did 9 and 3, right? So if we had x squared minus 9, that could be factored out. We know that the square root of 9 is 3. So we could write that as x plus 3 times x minus 3. Because we know that the middle term would cancel each other out. And we know that 3 times 3, the positive 3 times the negative 3 would give you negative 9. All right, so this is called a difference of 2 squares.